My name is Arun Gupta. I'm super excited here to be with Ravi. Hi, Ravi.
Here,
Yeah, I lead the open ecosystem team at Intel. You can find us more about us at open.intel.com. We have a wonderful podcast as well that you can go to open.intel.com/podcast and follow us on social media as well. Today, we are really excited to talk about the launch of M7i instance on AWS. Ravi, why don't you introduce yourself first?
sure. Hey everyone, I'm a senior principal engineer in our ASEAN software group, and I drive software engagements with AWS. So yeah, great to be here. Thank you for
Excellent.
this opportunity.
Beautiful. So, as I realize, M7i was launched over a month ago. So, tell us what M7i is and what is the hoop.
Great, yeah, sure. And let me share this material that I have. I'm gonna uh, share so,
Yeah,
just a couple
share
of
it.
slides just to use
Yeah,
it as
share it again.
context. Okay, there we go. All right. Okay. So M7i was launched on the 2nd of August, as I mentioned. These are based on the Intel fourth generation Xeon Sapphire Rapids processors. This is, Gen 7 on Intel in AWS. So that, speaks to the long-term partnership that we've had, which is, dating back to 17 years. So it's been a much deeper partnership in the Sapphire Rapids generation because we've done a lot more together than just the CPU being made available, as I've listed here. M7i has a bunch of new things. Obviously, there's higher performance. There's new instructions, specifically the advanced matrix extensions, AMX, and we'll talk about the implications of that. But there's also enhancements to some of the instructions that were available in prior generations, like AVX or like Crypto NI. One of the other standout features is the performance counters are now available in every instance size. Besides all this, from the CPU point of view, there are a lot of platform enhancements that AWS has introduced here. There's memory channels, there's DDR5 improvements, and PCIe Gen 5. You can go up to 128 remote block storage EBS volumes. In the prior generation, the limit was 28. And there's also an upcoming launch with the metal instances that will have both a single socket and a dual socket metal. And the R7IZ instances, which are also based on the same processor generation, were launched on September 6th, I believe. So the instance information is there in these tables. Of course, you find that on the AWS website as well. Uh, and up to the 24XL size on M7i is a single socket instance, which means there's no NUMA. And the M7i 48XL goes up to 192 vCPUs, and that's a dual socket instance.
That's amazing, actually. Let's break it down a little bit. So, this is Intel Xeon fourth generation, but on AWS, this is the seventh generation, and that's what the M7 stands for.
That's right. Yes.
Okay.
And now they've done the M7i and the R7IZ, and we're expecting the C7i and R7i to follow shortly as well.
So, M is the virtualized instance. What is R?
So the M is, they're all virtualized, but the M is the what I would think of as the mainstream instance in a way. But as you can see, the vCPU memory ratio is 4 GB per vCPU, and the R has 8 GB per vCPU. That is the primary difference in terms of the M and the R. I believe the C is termed as compute optimized, where it is 2 GB per vCPU similarly. And so that's how the nomenclature is used here.
Gotcha. And that's the standard AWS nomenclature. It's just
Right.
that Intel provides the SKUs around that, which are then available to the customer, so that is easy for them to consume.
That's exactly right. Yes.
And I love the part where you said, the block storage can go from 28 gigabyte to 128 gigabytes. That's a massive improvement over there.
Actually, it's the number of volumes. Each one of those can be much larger than 28 gigabytes. But effectively, think of it in the sense of, let's say you get the largest instance and you want to run a large number of containers and you want to associate an independent EBS volume with each container. And now you can do that up to 128. Earlier, the limit used to be 28. Right.
Got
So,
it.
those kinds of use cases get enabled now. So.
Got it. Got it. Fantastic. And you mentioned something like there are accelerators will be available. What are accelerators?
Okay, so there are fixed function acceleration devices. So QAT, which is the quick access technology, the Intel Analytics Accelerator, the data streaming accelerator, and DLB for hardware queuing. All of these are capabilities that will be available only on the metal instance. There'll be four instances each. We'll have, I'm sure, a follow up with a deep dive on this once the metal instances are available. But each of them can accelerate specific things like encryption, compression, data movement, and so on. And so you get outsized improvements way beyond anything that a CPU core can do if you can use the accelerator for them.
So, in a way, accelerator is additional hardware that is baked into the chip itself,
That's
which
right.
needs to
Yes.
be enabled by the software. So, you can say, hey, if the accelerator is enabled, my software is enabled as well. Kind of goes back to, software defined hardware enabled element.
Absolutely, yes. It's part of the CPU. It uses a device driver to be exposed into the operating system, and there are libraries available which let the user space software utilize these hardware devices and take advantage of them.
That's wonderful. And we will have a separate detailed session on accelerator itself, but that's coming later. And talk to me about the link at the top. What is that link about?
So that gives an overview of I think, the partnership that we have between Amazon and Intel, and it has a few case studies and a few other examples. It's an overview of the kind of engagements we've been having, and that gets constantly updated. But it's meant to give a flavor of the uh, depth of the partnership and the history behind it.
Beautiful. Also, tell me, like, what are the regions and the availability zones? Usually, availability zones are all confined to a region, but what are the regions these instances are available in, and what can customers expect going forward?
Right now, they've launched only in, I believe, four regions, but I'm sure that this will roll out very quickly. We're no longer, I guess, suffering from some of the supply chain challenges that were there a couple of years ago. And the R7iZ is also limited right now to a couple of regions, uh, but we are expecting that this will roll out across all of the top 10 regions very soon.
And that's the nature of it. I mean, it always starts with two regions at AWS, and then slowly, based upon the customer need and obsession, it grows across the region. And you mentioned 17 years of partnership. I think, and I think what that gives us is across these seven generations that AWS customers have seen us is we are there in all regions, all availability zones, essentially.
That's exactly right. Every single region, every availability zone, every service that offers the choice of choosing an instance definitely has an Intel instance. That makes us the incumbent, which also means that the barrier is higher sometimes in terms of making these available because they have to first deploy it and roll it out much more broadly before they actually launch.
Yeah, correct. And then from customer perspective, essentially, if they are building an application, they know, they can just go. I mean, if their application becomes viral, which happens quite instantaneously these days, they know they don't have to worry about ice or anything like that because they can just scale it across the world.
That's exactly right.
Beautiful. All right. So what else you got? Show us more.
Okay, so this is an overview of the performance improvement that you can expect, and these are numbers for generic workloads. And as the blog mentioned, you can expect to see about 20% higher performance. And the main reason for the higher performance is a combination of higher frequencies on the M7i instance. It has a much larger L2 cache. There's also much better instructions per cycle that it delivers because of all these. There's also much higher performance improvement for smaller instances. This is based on the feedback that we got speaking to a lot of customers and that Amazon also received from customers, where they indicated that they consume smaller instances a lot more often than the much larger ones. And that's why the design is meant to be this way. And AWS has introduced something new with the M7i Flex option. That's quite interesting because it is priced the same as the M6i, but it has the same performance as the M7i. 95% of the time is the disclaimer, so to speak. But what it effectively means is, unless you really have a workload that is saturating the CPU all the time, you're probably not going to see any impact from this, and you're probably going to see the full 20% performance improvement that you might expect without any actual degradation. So it seems like something that's worth trying out.
So what I'm seeing here is for customers. Well, before I jump into that, what is the price point for M7i straight up? Like, is it like how is it higher, same price, cheaper? Because you talked about M7i Flex. What is the price
Okay,
point for M7i?
so M7i is priced about 5% more than M6i. And the M7i Flex is priced the same as the M6i instance.
Gotcha. Okay. So for a 5% higher cost, you could get 20% higher performance per vCPU, which is pretty amazing.
Yeah,
And then if you want to pay the same cost, and as you said, if your workloads are not saturating the CPU, then you can get 95%, and you are okay with 95% of the time, 20% higher performance. Go for M7i Flex, essentially.
that's right. And the benchmarks here below are showing much higher than 20% improvement. But again, these are benchmarks, and they're very well tuned. So we expect general purpose workloads to see here that 20% approximately, but you're likely to experience even higher. Uh, and what you're seeing is three examples. One is WordPress, which is still very commonly used for hosting websites. This is with encryption, so it uses TLS 1.3, and the ciphers used are mentioned over there. So this is a measurement of the throughput improvement that you're seeing with the M6i in orange and the M7i in blue. The one in the middle is for a database. So it's a HammerDB, which is a TPCC like uh, implementation against MySQL. And this is showing the number of operations per minute or an OPM metric. And this is, again, orange is M6i and the blue is the M7i performance relatively. And the last one is a service mesh Istio Envoy performance measurement, which is also showing both the request per second absolute values and on the y-axis, as well as the line that indicates the relative performance improvement between the two generations. So, pretty much a broad set of performance improvements on all of these three examples that we're showing here.
Yeah, and these three are very typical examples, like WordPress database and Envoy. These are very typical workloads that customers are running in production today. And to your point, yes, these are highly tuned benchmarks. So customers would really want to run their own workloads and see how it operates and behaves on that part of it.
Yes, that's exactly right. And let me switch to the switch and launch.
Well, actually, before you
Launch
switch to the next that one, I also want to
Yes,
highlight the second bullet here, which is very true, because the customers that run larger instances are not like there are many, but the customers that run smaller instances is a lot larger. So I think
yes,
the second bullet is catering, again, going to the Amazon's customer obsession principle, is really catering to that large set of customers, because 20% is something that we have seen, but you could potentially get more, for those smaller instances.
absolutely, yes.
Okay, what else you got?
Okay, I mean, let me share this slide and then I can go show the instance. But this is very quick, brief overview of the kind of performance improvements you're seeing with Java using the OpenJDK 17 or the Amazon Corretto 17 distribution. These are Java micro benchmark harness results, or JMH, for a wide variety of what we call as primitives. Right? So encoding and decoding, checksum, math functions, cryptography functions, and so on. Now, all of these are showing, a huge performance improvement. Some of them are, much higher than the others. Obviously, all of this is dependent on how these primitives are benefiting from the performance optimizations that have been done and implemented. And it is the same JDK 17 that was used on the M6i in orange and the M7i in blue. So, there'll be a deeper dive on this one later on. So this is just a very quick overview of the kind of performance improvements that you can expect to see with primitives.
And what you're saying is the blue, the taller is better, and we're seeing far more than 20% in lots of cases.
Right. And the way to interpret this is, if your application is spending, say, 5% of time on encoding or decoding, you can expect this much, 30, 40%, as seen in the first column, if you will. You can expect this kind of performance improvement on those. If your application is spending 20% time on cryptography and checksums, for example, this is the extent of performance improvement you'll see for that. So
Got it.
these are not application level benchmarks. These are micro benchmarks
Micro
effectively
benchmark.
that are looking at from this.
Oh, great. And we will have, as you said, a deeper section on Java on how we have optimized OpenJDK to run best on M7i. Right. What else we got?
Okay, so I mentioned this advanced matrix extensions. Uh, a lot of people have heard about AVX and AVX 512 from before, which are the advanced vector extensions. So these are advanced matrix extensions. This is new, introduced in Sapphire Rapids. So the M7i instances and R7iZ are the first instances in AWS that have these, and they are primarily used for AI inference performance. And the charts below are giving you a sample of the extent of performance improvement that is possible here. I'm showing in a few examples that across recommendation systems, natural language processing, and also vision, which is the rest next 101. So if you look at all of these things, uh, it's a staggering level of performance improvement. And there are two comparisons done here where both M6 and M7i use the int8 data type because M6i has the VNNI instruction that supports int8. And the second comparison is the M6i is using the FP32 data type and the M7i is using bfloat16. And this is fairly popular because it's quite straightforward to use an existing FP32 train model and run it with bfloat16 on a CPU, just chopping off the additional bits, if you will. You don't need to quantize and do all of that, which you need to do for intake. And the performance improvement is anywhere from more than 2x to almost 8x. So that's a massive performance boost. And just as I mentioned, the flavor of the day is, of course, LLMs and Gen AI. There's a lot of performance data that we have that is showing that for fine tuning and for inference on LLMs, AMX on Sapphire Rapids and the M7i or 7A instances are good enough. But there'll be a lot of data on that next week in Intel Innovation Event, so we should do a follow up for sure in another session where we deep dive on that also.
Absolutely. And you're absolutely right. The training could happen a lot on the GPU side of it, but heavily the inferencing happens on the CPU side of it. And so, in that sense, the way I'm thinking about this is now M7i is available on AWS. That really opens up the opportunity for people to have that highly optimized, fine-tuned inferencing on AWS, particularly with LLMs and 2x to 8x performance. Who doesn't want to get that?
Yeah, exactly. Yep.
All right, what else we got?
Okay, so let me switch to launching an instance and showing what you can actually see. Give me a second. Let me start sharing that.
Fantastic. Okay, I'm going to move the slides away.
And let me bring this over here. All right. This is just the standard AWS web console for instance launching. So I'm just putting in the name for testing. I'm choosing the Amazon Linux machine image. You can choose an Ubuntu 2210. Essentially anything with a 5.19 kernel and above is recommended, but you can use any kernel version, it will work. But for the ideal performance that you would like to see, 519 and later is recommended.
Well, that's a very important point, though, as you mentioned it, because what Intel has done over the years is we have been contributing to Linux kernel so that when Sapphire Rapids, which is basically Intel Xeon 4th generation or M7i, goes live in a CSP, we have been working in the kernel community so that all the feature enablement happens in the kernel community, happens in the downstream distribution, so that from a customer perspective, essentially, they say, I want to launch M7i, and as long as I'm compliant to a certain version, in which case, in this case, you mentioned 519, voila, I'm going to get all the best benefits out of the box.
That's right. That's exactly right. And we'll go over, when we come back to the slides, we'll go over some of those recommended versions of software and so on. So this is basically launched right now, and I'm gonna, use a Windows system for Linux WSL console to just log into it. I should probably share that as well, otherwise
Yeah.
it may not be visible. So let me switch to sharing my entire window. Give me a second.
So what you just did is you basically went to the AWS console and you said, okay, I'm going to launch an instance here. You pick the M7i instance. You picked any of the downstream kernels. Um, you picked up Amazon Linux because you know that is 519 compliant. So you are running on the latest Xeon instance, the latest operating system. So you'll get all the benefits out of it.
That is right.
Okay. And can you make your window bigger and the font slightly bigger?
Oh yes, sorry, I should have done that right at the beginning.
That's all right. Oh, that is so pretty to read. Thank you.
Okay, that's much better. I'm just logging into the IP address that I copied from over there. Okay, and Amazon Linux 2023 has this cool logo, which I really like. So kudos to those folks for all the work that went into Amazon Linux, but also for the logo.
Yeah, I mean, open source developers got to have some fun.
Absolutely. So yeah, I mean, I'm just running an LSCPU just to show you what it looks like in terms of the output. So yeah, I mean, it's a 8488. The 4 here is if it's essentially what signifies for Gen. But the ones that we're interested in, as I mentioned, AMX, and in the CPU flags, you see support for B416, AVX 512 has FP16 support, but AMX tile, Int8, and so on. That's really what indicates that this has support for AMX. If you run on an older generation of kernel versions, uh, essentially older than 515,
Yeah.
older than 517, sorry, you will not see these. And of course, something like RHCL, that has it backported. So even on an older kernel version that shows up on enterprise Linux distros, you will still have this support. Okay, so that is one thing. The other thing is, let me do a very quick. So Perf is a Linux tool that is used for performance monitoring. And if you do a Perf list here, as you can see, this is a 4XL instance, and you see a lot of these hardware instructions that are supported. This is something new and unique, as I mentioned, on Sapphire Rapids instances. So previous generations like M5 or M6i, you needed to be on a single socket size instance or full size or on a metal instance to be able to see these. So this makes it much easier to do debugging, troubleshooting, and we'll do a deep dive on this one as well to show you what the use cases are and how it benefits people. So far, I think not many people are aware of this. Only a few power users, companies like Netflix that we partner with, use it extensively. They've blogged about it, but this is something I think that should be, we should do more to build awareness on this.
Right. So these are the performance counters, hardware performance counters that you were talking about earlier, right?
That's right.
Got it. And yes, we will have a deep dive session on this.
All right, let me come back to the numbers here. And this is just an overview of, it's a good segue here for this. It talked about the core performance counters and off-core registers that are now available. And this is also supported, back to the point that Arun made. We work with the open source community extensively across Linux and every other software stack. So these are supported in Linux Perf. There's a Perf wrapper called Perf Spec, which Intel has released, which is also open source, and that has additional formulas for metrics built into it. So it makes it much easier. And PCM, which has been a tool with users Linux Perf that's been out there for a long time from Intel, also open source, also has support for all these things. And the 3 bullet points here are examples of the use cases. What can you do with the deeper troubleshooting or a fleet-wide analysis? A lot of people look at CPU utilization as pretty much the primary metric, and that's really very inconclusive. I would call it a very naive metric to base decisions on, because different generations of vCPUs and CPUs are not the same. And if you're running a turbo and if you're running at different frequencies, utilization doesn't mean the same thing. And if you're using a ISA like AVX or AVX 512 versus you're not using it, also utilization means something else. So what we really track is instructions per cycle or IPC. If something like that changes, you know that there's something that you need to, do faster and easier debugging, because in many cases, something like a cache miss isn't otherwise easily identified as the cause of a bottleneck or the reason that or a potential option to optimize. And if you want to do very granular debugging and metrics collection because you're trying to identify why there is slowness, right? Trying to do it in software can introduce more overheads because the sampling rate and so on has an issue. And here, this actually it can be much more efficient to do so.
So this is beautiful actually because this feature truly allows you to dig deeper into what's happening at the chip level, yet enable at the software level.
That's right. So, I mean, in a microservices scenario, you might find that, okay, I'm trying to look at my traces and I'm seeing that this individual service has now taken longer to deal with requests than it used to. Then the question becomes, why is it taking longer, right? The default, solution that a lot of people go with is just throw more resources at the problem, get a few more replicas or instances spun up. But this kind of deeper view can help you identify what actually happened at that time and what can, I mean, it may not be a first order problem for many people, but there are a lot of very advanced users that have been optimizing their microservices, the different layers of software, and I think they'll benefit a lot from having this level of visibility.
And I think the point that you mentioned in the beginning is also very relevant, where you said we this kind of fundamentally explains Intel's open source philosophy that we we contribute to open source because our customers, who are our silicon customers, they consume our product and they expect that all of these features are going to be enabled by default. So that's the reason we Intel contribute to 300 plus open source projects so that they're optimized out of the box and give all the beautiful experience that you're talking about right now.
Exactly. And that's a good segue to this next slide, which is really talking about some of the recommended software versions. So, as I mentioned, you can use pretty much any version, old one that you have on SPR, and it will just work. That is one of uh, you know, the reasons why backward compatibility matters, and we do make sure that all of that is supported. But you may miss out on the performance that you can get going to a newer version, right? And now, when it comes to AMX, there is a 1DNN library from Intel that has been included in PyTorch and TensorFlow. There's a link in here. We'll drop some of the links for the other aspect that I mentioned as well later. But all of this is usable directly. You don't need to do any additional enabling. For Java, I strongly recommend looking at OpenJDK. Uh, uh, Most people, I think, are on JDK 11. Some are still on JDK 8, but 17 is a huge improvement and is also a target for backports from 18, 19, 20, and 21. So there's a lot of optimizations that have gone into even future versions that have been backported into 17, which it's not practical to backport any further, which is why 17 is a good target. Even on GCC and glibc, GCC 12 does auto vectorization. This is worthwhile to mention because all prior versions of GCC does not auto-vectorize, meaning it does not even use SSE, which is an instruction that was introduced, I don't know, more than a decade ago. But GCC 12 does auto-vectorize, so you can take advantage of all of the, some of the hardware features. There's probably a deeper dive we can do on some of those in terms of what you can do more with that. Uh, and of course, for operating systems, there's the table over here. Not all of these features will be of interest to everyone. And the last column is the upstream kernel versions where support was added. But as you can see, different vendors of operating system distributions have incorporated support in different versions. So this is a good ready reckoner, if you will, for anything that might be of interest.
Got it. And where can people find out about this column, the recommended software stack?
We'll be posting it. I don't know if all of this is in a single place right now, but Arun, I can work with you. Maybe we can make it available under
Yeah,
open.intel or somewhere else. Yeah.
absolutely, absolutely. Because see, what I'm hearing is WordPress, HammerDB, Envoy, JDK, inferencing, Java, PyTorch, TensorFlow, GCC, operating systems. I'm hearing a large slew of open source projects that are optimized. We have worked on this for several years to make sure they all align with the launch of M7i, as you were saying, SPR or Sapphire Rapids, which is our internal code name for it. So that's wonderful, actually.
Yep. So yeah, this was a very quick overview of M7i. You can see similar results, actually even better with R7iz. R7iz has fewer instance sizes. The largest goes up to 128 vCPUs, but the frequencies are even higher. You will see, I believe AWS has mentioned or called out that it's basically the fastest x86 instance available. I think some of the customers have used it during the private preview, and now it's generally available. Yeah, I mean, the Z suffix indicates that it's the high frequency instance, so it's targeted at specific use cases. So
Got it.
that is also quite an interesting one.
Got it. Got it. So, I mean, customers don't have to do anything different or anything new to make this work. They just go to their console, they launch a M7i instance instead of picking up a M6 or R6, they would pick a M6 or a R6, and voila, just pick up the latest stack and ready to roll.
That's right.
Awesome, Ravi. I really enjoyed this brief discussion. And as we have hinted on the channel, we are going to schedule several deep dives that we are working on. So I'm looking forward to this partnership. Our request to you is give M7i a try, give M7i Flex a try, give R7i a try. Let us know what's working, what's not working. As much as Amazon is customer obsessed, we are equally customer obsessed. That's the reason we contribute to these open source projects.
Yeah, and we'll have AWS along with us next week at Intel Innovation, presenting a session on the future of cloud that will be recorded and posted. So for those of you attending, we'll be happy to see you there. And for the rest of you, we'll definitely post it, and I'm sure Arun will include it in the links and material that he's amazingly well stewarding over here.
Absolutely. And then likewise, the Intel team will also be at reInvent later this year, where we'll be talking about these features. So feel free to swing by our booth at reInvent.
Yeah, absolutely.
Awesome. Thank you, everybody. I will see you at a later time.
Thanks, everyone. And